I'm recording some video, and so I'm just going to walk through some of the material I'm sending you to help with your homework this week. We're going to be looking at chapter 12, sections 1, 2, and 3. So sections 1 talks about a polyhedron, which is a solid figure. So I have a definition for what a solid figure is right here. And essentially, a solid figure is an enclosed part of a 3D space. To help you think about this, compare a thin piece of paper, which represents a two-dimensional object, to a block of wood, or ball, which represents more of a fully formed 3D object. And then if you think about solid figures, there are specific solid figures that are called polyhedrons. And polyhedrons are solid figures with flat surfaces that are polygons. So anything can be a solid figure, but not all solid figures are polyhedrons. And that's where these figures come in place. Figure A is what you will learn is a pyramid, really. Think of Giza, the Pyramid of Giza in Egypt. But figure A has flat sides, which are all triangles. And I could pick out the sides if you're looking. That's the triangle C, D, B, and A. I could pick out sides C, D, and A. I can pick out sides B, A, D. I can pick out sides C, B, D. And what you would notice is that all those sides, all the sides of this solid figure are flat, and all the sides are also polygons because they're all triangles, they're polygons. So this solid figure, figure A, is a polyhedron. If I shift left to figure B, I can see a cone. Think an ice cream cone if you went to Jenny's ice cream to get some refreshments, I guess. I don't know what they sell there. So you have a flat space, which is a circle. Already that's a red flag because we know about circles from what we've done in our past work, that circles are not polygons. They are not polygons because they have curved edges, which are not considered a polygon because a polygon has straight edges. And then everything else is a curve cone. So none of those edges are flat. So basically figure B, even though it's a solid figure, is not a polyhedron. And I think I would just write it there. So yes for figure A and no for figure B. And if we go to figure C, we have a box, or the acute name would be a rectangular prism. But as we can see, all the sides of this box are flat. All the sides of this box are polygons because they're all rectangles every which way you look, or quadrilateral. I guess it's not specified, which makes figure C, yes, a polyhedron. Now figure D that we have here, now we can see it actually is a cylinder. So think of a canned soft drink you'd have, that's a cylinder. A Pringles box, that's a cylinder. And what we know about cylinders is that it's all curved around the sides. So that's your first red flag. So we know all around, we don't have a flat surface. So we can't really call figure D a polyhedron based on that condition. So figure D is a solid figure, but it's not a polyhedron. Okay, and now that we can agree that figure A and figure C are polyhedron, what are specific characteristics that they have? One thing we learn in the book is that polyhedrons have faces, polyhedron have edges, and polyhedrons have vertices. And these things, three things, are very well defined and specific to a polyhedron. So what is a face? That's the first one we're going to look at. What is a face? Faces are 2D surfaces that make up the sides, in quotes, of a polyhedron. So for figure A, if we scroll back up, we can see that each of these sides, the triangle side, so if we could write that down, that would be triangle CDA. I'll probably see if I can write it this way. We can see triangle CBA. We can see triangle BDA. We can see triangle CBD. And these triangles are very well defined. They're flat surfaces and they make up the sides of that pyramid. So we can call them the faces of figure A or the pyramid. So we can have four faces. I wrote in there CBD, CBA, CDA, and BDA. And figure C, being a polyhedron, we can also pick out the faces. And this is a rectangular prism, and all its sides are rectangles. So we can pick it up easily. We can see rectangle up top, BADC. We can see the rectangle EFHG. We can see the rectangle ADEH. And on the side, we can see the rectangle DCHG. So all the sides are rectangles and they're well defined. So in figure C, we can write right here, we can write that the faces of this polyhedron are quadrilaterals and there's a total of 6 faces. And the last thing we have to learn are edges. And edges, I'll mark it, are line segments where two faces intersect. So if you look at back to figure A, where are our faces, which are our flat surfaces, meeting? They are meeting across some edges. So the first one we can see is where, for example, CDA meets CBA. So that's a triangle CDA. So that side of a triangle, where does it meet? CAB, and it meets across the line CA. And therefore, in that scenario, CA, line CA, will be our first edge. And so if we continue that logic, we can actually pick up 6 edges for that pyramid. So we have line CD, CA, CB, BD, BA, and AD. And likewise, in figure C, we can have line segments BC, BAB, AD, DC, CG, DH, GH, EF, GFG, EF, that's EH, sorry, EF, AE, and BF. So these are places where two faces meet, and the faces being the sides, which are polygons. Okay, so a vertex is just the tips of a polygon. So if you look at figure A, for example, C is a vertex. It's where edges meet. So edges CD and CB and AC meet at C. So C is a edge. And so we use that logic. So three or more. So give me a second. So edge would be where three or more, sorry, vertex, sorry, we three or more edges meet. Mhm. So that's what we call a vertex. Okay, and I wrote the definition there. And so the next thing we can pick out will be for figure A, the vertices being A, B, C, D, and in figure C, the vertices are A, B, C, D, E, F, and H, the G and H. Okay, so now let's move to this polyhedron. Uh, and we have uh, 6 sides that are rectangles, and we have 2 sides that are hexagons. So the question now is this solid figure a polyhedron, and why? I guess I've already answered this, so I'll just go ahead and say yes. And the reason being is that all the sides, we clearly state, are very well defined as polygons, and they are all flat surfaces. So we have, and because it's made up of 2 hexagons and 6 rectangles, so that's what makes it a polyhedron. Can you attempt the next 3 questions? Just pause this video, and then I'll give you answers. Thank you. Awesome. So I have it all written out here. So yes, it's a solid figure because it's made up of 2D flat surfaces that are all polygons. So at any point, if any part of this was curved out, wasn't a flat surface, even though most of it was, we wouldn't be able to classify it as a polyhedron. All the sides have to be flat surfaces that are uh, polygons. So name the faces. So like I said earlier, we have two hexagons up top and at the bottom, and those are A, B, C, D, E, F, and hexagon G, H, I, J, K, L, and then the rest are quadrilaterals A, F, L, G, A, B, G, H, B, C, H, I, C, D, I, J, E, D, J, K, and E, F, L, K. So how many edges do we have? So, and name three of them. So, what are edges? So, by our definitions, edges are where two faces meet. So, if I was to outline, I would say this is an edge, this is an edge, this is an edge, this is an edge, this is an edge. And practically, what you get to the point is that anywhere you see an outline is an edge. So, you just count pretty much how many lines you have, and you keep going. And that's all about 18 edges in total. So let me remove that so it's clear. So edges being where the faces meet are those sharp lines that you see, and we can pick three out for the answer, and those are lines AB, lines DC, lines CI, and then vertices is pretty much all the nodes of this polyhedron, and so all the sharp points, and you can see with everyone that's where three or more edges meet. So we can pick any of the letters work: A, B, C, D, E, F, G, H, I, J, K, L, pretty much all of them vertices. There you go. And so the next one we have is a pyramid with a four-sided base. So the question now is this solid figure a polyhedron? State why. Name the faces. How many edges? Name three of them. How many vertices? Name three of them. And yeah, take your time. You can pause this video, attempt it, just give your best guess, and I'll go through the answer in a second. Thank you. Okay, so the first question is this solid figure polyhedron? And the answer is yes. Uh, the answer is yes. Why? Because no, all the surfaces are flat. Up top you have three triangles, and at the bottom you have a rectangle. And we know it's a rectangle because I've actually specified that all the angles in there are right angles, and the sides match up. And so we know that they are flat surfaces and therefore it's a polyhedron. The second thing is name the faces. And so, like we said, four triangles, my bad, up top, which are triangles ABC, ABE, AED, ADC, and then the rectangle that makes up the base of this polyhedron, BEDC. And then how many edges? Again, just counting all the lines. And so there are 8 lines in total. So there's eight edges, and then naming some of them, which is AD, BC, and ED. And then the last question is how many vertices, and name three. And vertices, just think about all the points in this polygon. So we have E, B, C, and D. So 5 vertices. A, B, C is 3 examples. So the next thing we're going to look at are specific kinds of polyhedrons called prisms and pyramids. And so each one of these type of poly of these each of these types of polyhedrons have specific criteria that makes them what they are. So obviously first is that for a prism is that it is a polyhedron. So it has to be before you can call it a prism, but it has two bases and they're end-sided faces which are parallel copies of one another. So that's how we define them. So there are two end-sided faces that are parallel copies of one another, and we call these two faces the bases of a pyramid. So look down in figure 1. We can see the top, that's the hexagon, and the bottom, the other hexagon. They are two n-sided polygons, six-sided, and they are parallel to each other. So they are facing each other. And they don't have to be aligned, but they have to be parallel. So I can't tilt if I tilt the top hexagon down to a point where it's no longer parallel, then it's no longer serves as a base, the second base. So in this image, we have the top as a hexagon as a base and the bottom as a base. And these two are specific because the next part is that what a lateral side is that we have bases and a lateral side that makes up prisms, but they have to be joined by a straight line. So a lateral side are the lines joining both bases, and they're called and they are faces, sorry, but they're called lateral sides. Let me say that again. A lateral side are faces joining both bases, and we call these faces lateral sides. So the way you think about it, and that's why, and is that the way you think about it, and that's why we can only select the two hexagons as our bases, is that we have a base up top, that's hexagon A, B, C, D, E, F, and we have a base at the bottom, which is hexagon G, H, I, J, K, L, and you can see that you just have straight faces joining both this uh, hexagons. If I try to make any of the rectangles a base, even though they're parallel to their opposite sides, I don't have a straight face joining both. So I have to go past two faces to get from somewhere like ABGH to EDHKJ. And so you see where the problem is. So you see why I can only select the top and the bottom as our bases. And so if you select those as your bases, every other side becomes a lateral side because you see they cleanly connect both bases. So our lateral sides are the six quadrilaterals AFLJ, G, ABGH, BCHI, EDJK, EFLK, and that's it. And also, with prisms, you name them based on their base. And one thing you can check about a prism is that a prism will only have one name because there's only one way to make it work. So this one, the only way it works as a prism is if our bases are the hexagons. And so because our bases are hexagons, we call it a hexagonal prism. And that's how we define this figure. So this figure is a hexagonal prism. Okay, and so the next part is we've defined a pyramid. So how do we define? So we've defined a prism. How do we define a pyramid? And a pyramid also is a polyhedron. It has a single-sided polygon to serve as the base, and all other faces are lateral faces that meet at a common vertex. So if we look at this figure 2, which I pulled out of the example, we see that we have a rectangle as a base. That's rectangle BCDE, and we have four lateral sides, and those four lateral sides all meet at a specific point, which is a common vertex. Yeah, and that's it. And we call it we address it based on its base, which is a rectangular pyramid. So like how if the top one was called a hexagonal prism, this one is called a rectangular pyramid. And so an example now is we go to this box, and the question now is what type of prism is this box? I mean, and so I picked this figure specifically because we have what we call a quadrilateral prism. We don't, it's not specified what kind of quadrilateral it is, but as you can see, any side here can serve as the base without breaking any rules. So I can say that I can select the top and bottom as I see it as my bases, but I could also select the front and back as my bases. I can select the sides as my bases. But no matter how I orient this figure, you can see that it only has straight lateral faces connecting both sides. And so any way it works, any way I select the base, it works. But we also see no matter how I pitch this, it would always still be a rectangular or quadrilateral prism. Mm. That will never change. Mm. And so that's a good indicator is that if the type of prism doesn't change based on how you define it, then you know you're good. If it changes, then you know something is wrong. So this is a quadrilateral prism, and name two bases. And like I said, you can select any other base, but we can pick the top and the bottom based on this orientation. And so that's quadrilateral, and probably put quadrilateral A, B, C, D, and quad E, F, G, H. Okay. And then the next part is this interesting guy. And what type of pyramid is this? We know it's a pyramid. I can go back because we can only have one base at any given time. The question now is what type? And so we look at the orientation that we have here, and let's just try and use BAD as a base. What type of shape is that, or polygon is that? That's a triangle. So if you're going to call this, you probably go for a triangular pyramid. And it works because we have a base as BAD, and all the sides converge. All the other faces, which are lateral sides, converge at a single point. The one specific thing, though, about a triangular pyramid is that any side works as the base as well. So I picked these two examples because they are easier, more difficult to pick, but no matter how you so you have more options to pick from as your base, but no matter how you orient this image, the type of pyramid doesn't change. So this is a very well behaved. These are two well behaved prisms and pyramids. Okay, so the next part is looking at two figures that we had at the beginning. The first one was a cone, and the next one was a cylinder. And why I wanted to particularly pay attention to this is that even though these two are not polyhedrons, they take some characteristics that we're going to use later. Because as we look at it, we can call the top of this cylinder a base, and the bottom a base too, because that's very similar to how we would call a box, like if you look at figure C. So a flat surface at the top and a flat surface on the bottom, and then sides. So even though we can't call it a polyhedron or a prism, we can still acknowledge that it has two bases. And in the same way for the cone, we can still acknowledge that it has a common vertex up top, and it has a flat surface at the bottom, which a flat circle at the bottom, which we can call a base. So just something to think about. So even though these two are not polyhedrons, that you can still they have some similarities. And then lastly, we have something called composite. Give me a second. We have composite polyhedrons, and those are when we join two composite solid figures, sorry, when we join two or more solid figures together to make one bigger one. And so the first one is figure E. We have a cone on top of a cylinder, and so that works, so it's a solid figure. And then we have the second one, which is a rectangular prism on top of another rectangular prism for figure F. That makes a big T.